All right, so we're going to do some KEQ problems. Now we are going to start with, let's do number 9. Okay, so KEQ is the ratio of concentration of products divided by the concentration of the reactants, and that gives you the equilibrium constant. So first, we're going to start with the products, put those on top. Now concentration is represented by brackets, so we're going to put HgI2 on top, and then divided by the concentration of the reactants, which is G concentration. And then multiplied by the concentration of I2. Okay, equals KEQ. Now this one's super easy because it doesn't have any coefficients. Okay, coefficients make it a little bit trickier. So let's do number 1 next. Okay, so again, we're doing the products over the reactants. So that's concentration of H2O. Okay, but this is a little bit different because the H2O has 2 for the coefficient. So anytime we have coefficients, we have to put those as exponents, like that. Okay, so now we do our reactants, H2, and then the coefficient of H2 is 2, again, so we put that as the exponent, and then O2, concentration of O2, and then that does not have a coefficient, so we just leave that, and that equals KEQ. Okay, now there's one more slight complication. All of those ones that we just did were all gases. Okay, so the only thing that actually goes into the equilibrium expression is gases or aqueous solutions. If you have a solid or a liquid, you do not put that in the in the KEQ expression. So we're now going to do number 10, and let me erase some of this stuff a little bit so we can see 10 a little bit better. Okay, there we go. All right, so we have products over reactants again. So we have our products are SN and CO2. Problem is SN is a solid, so we just pretend it's not there when we're doing the equilibrium expression. So we just do concentration of CO2, and then CO2 has a coefficient of 2, so 2 as an exponent, divided by our products, and again, SnO2 is a solid, so we just pretend it's not there, and CO2, CO, concentration of CO, because that is a gas, and then it has a coefficient of 2, so we're going to put the 2 right there, and that's it. Now, sometimes we have, hold on a sec, we have an issue like number 13 here. Okay, so these are liquid, liquid, liquid. Okay, so what we're going to, so we only have one thing, our gas, which is a solid, our potassium, which is a gas. So the equilibrium expression is going to be concentration of K, and then it doesn't have a coefficient, so there's no exponent, and there's just going to be nothing on bottom. So you can either just leave it as concentration of K or put it over 1. Either way is correct. And that is everything. Oh, actually, one more thing that I wanted to say in here. If you had something where you had only liquids and solids on the product side, and you had a gas on the reactant side, so for example, let's pretend that this one here, the CO2, let's pretend that it is a solid. Okay, so we would ignore Fe and CO2. We'd also ignore FeO. So we put our products, which both of them aren't there, so we just put a 1 on top. And then we would put our reactants, CO, concentration of CO, on the bottom. No coefficient, so no exponent, and that would be it. Equals KEQ. Also, this one was equals to KEQ. Okay? And that is it for this one.